So here's a summary of the key selections to make in the design of a standard filtration system. This isn't a superior filtration. This is just standard. We're familiar with most of these. Obviously, we need to determine if it's going to be a gravity or a pressurized system. What is the peak flow rate in gallons per minute or liters per minute? What is the filtration target for the irrigation emitters, the standard component-centric questions? And what's the pressure and allowable pressure drop across the filter? This last one, this one is missed by a lot of growers, not looking at the pressure requirements of the filter. Effective filtration is very pressure dependent. And what's the allowable pressure drop in sizing the filter? If you've got a filter that does an effective job of filtration, but it immediately blinds and raises the pressure drop too high for your irrigation system, obviously it's not an effective filter. And then the question of backwashing or non-backwashing. Again, this is becoming more important as more states and municipalities adopt restrictions on backwash from filters. In the state of California, for example, the state says no backwashing from filters is allowed. It's not necessarily policed, so there are a lot of growers that are still backwashing filters, but it's important now to address the question in the design and know what the answer is before you select a filter system. You don't want to spend a lot of money on a filtration system that's backwashing only to find out that you can't backwash for a year from now. So here are some additional considerations, key considerations that need to be addressed for the design of a superior plant-centric filtration system. Water chemistry. This one's overlooked all the time. What's the pH of the water? Certain particles become colloidal or non-colloidal depending on the pH of the water, such as iron. Iron wants to precipitate out at higher pH levels. It wants to stay in solution at lower pH levels. So how your filter is going to work and what it's going to need to filter, how much iron it's going to need to filter, is going to be very dependent on your pH. And that's going to be dependent on the oxidizer that you use. Sulfur, hydrogen sulfides, manganese levels will all work together to determine the level and type of precipitants the filter system needs to remove and where it needs to be placed in order to remove them. The type of oxidizer that you're going to use for water disinfection will determine the type and the amount of precipitants you can expect and the level of biofouling and blinding of the filter that can be expected. The location of the filter, where you put the filter in the system. Will there be precipitated solids or emissions from oxidation, iron, manganese, hydrogen sulfide? Will there be accumulated organics from biofilm sloughing? Certain types of oxidants don't burn up the biofilm. It results in sloughing. Certain types of treatment of the algae. So then you have to catch it in the filter. Is there algae in the source pond that's going to be coming out? What filtration level? Are you going to go plant-centric? Or are you going to stay with a standard component-centric? That will determine the size of the filters and the frequency of media change or the backwashing that's required. Are you going to do single or multi-stage filtration? Is it reasonable to accomplish 100% of the necessary and the desired filtration, necessary being component-centric, desired being plant-centric filtration in a single filter? Probably not. Multiple stages comprised of different filter types and sizes will likely accomplish the job a lot better, much more efficiently and more reliably. Look at multiple stage filtration.